SOHCAHTOA. It's kind of important to know how to spell it too, because you know, if you don't get the letters right, you're not going to know how to interpret. Sine of the angle equals opposite over hypotenuse. Cosine of the angle equals adjacent over hypotenuse. Tangent. Alright. Number 1. Using the picture down below. Uh-oh. Okay, so they only put a 7 and a 2. Which sides were? So guess what we're going to need to do first?
Find the angle.
Pythagorean theorem. We don't have to find the angles on this part. So you can do x squared plus 2 squared equals 7 squared, or we could do backwards 7 squared minus 2 squared equals x squared. Does square root of 45 simplify? Question mark. It's 9 times 5, so the 9 turns into a 3. Square root of 5. Let's get all that stuff out of the way. Alright, that's not an answer. We just need to know that for the question. A. What is sine of B? Okay. I kind of switched around the A and the B. Usually it's the other way around, but I'll pick on somebody. Does anybody want to volunteer? We'll go around the room. Xander, what's the sine of B?
The sine of B?
Yeah, this one's B.
Oh, so 2 and 7.
2 over 7. And then it says cosine of B.
That would be 3 square root of 5.
Yep. Adjacent over hypotenuse. 3 square root of 5 over 7. Remember, if there's a square root in the denominator, you can't leave it. So you got to do like multiply top and bottom by square root of 5 and let your calculator do it. Also remember that if like 2 and 7 or 3 and 7, if that reduces, you should reduce it as well. Alright, and Xander, tangent of B.
2 over 3 square root of 5.
Tangent, yeah, 2 over squared. So that's a problem, right? You're not supposed to leave square root of 5 in the denominator.
So you just do.
So you plug in your calculator, or if you don't have a nice calculator, multiply top and bottom by square root of 5, and what do we get there?
2 square root of 5.
Yeah, square root of 5 times square root of 5 is 5 times 3 is 15. Does that reduce?
No.
No. Alright. Very good. Numero 3, a different picture. And they did not find the hypotenuse for us. Rude and crude. So, Craig, how could we find the hypotenuse here? Hypotenuse is always the biggest, so the 2 little ones should add up to it.
Okay, so 5 squared plus 2 squared.
Yeah. So it's 25. 34 is like 2 times 17, so it doesn't really have a nice square root. So we're just going to leave it like that. All right, Jarrett, which one is x? The top one. Jarrett, what would the sine of x be? Right, so x is up here, so the opposite is 3 square root of 34. So do you know what that's going to turn into? one's actually kind of easy. When you multiply by square root, so you multiply by the square root that's on the bottom. The top is just 3 squared root of 34, and the bottom 1 squared root of 34 times square root of 34. Okay, and that's it. Unless, like, if this reduced, you would have to do that, but it doesn't. So. Lots of weird numbers. Okay, and then the next one they asked for is cosine of x. So, Jared, what would cosine of x be? Right, adjacent, yes. 5 over square root of 34. It's almost identical to the last one, right? So it's just going to be 5 square root of 34 over. I don't know how this works. 5 square root of 34 over 34. And then what is tangent of x? Opposite over adjacent. By the way, if I wanted to find angle x, which we're going to be doing later, how would I do that? So if tangent of x equals 3/5, then you do tangent inverse of 3/5. You guys remember that? I don't know what number that starts on, but. Okay, number 5. I'm sure we forgot how to do this one.
Hey.
So we're still kind of like on lesson 1, but lesson 1 was like a 2-day lesson. It was a long time ago. I think it was before we did the ACT, or was last week the ACT? Yeah. Seems like so long ago. Okay, so the directions are find the other 2 basic trig ratios. So they gave us sine, so what or cosine. So what we're missing is sine and tangent. If cosine of d equals 5/13, what does that tell us? Draw a triangle. Call one angle D. That's not the can't be a 90-degree angle. You don't use 90 on the trig ratios. What does cosine tell us? My picture doesn't look right. Adjacent and hypotenuse, right? So 5 must be the adjacent to D, so I'm going to put it right there. And 13 must be the hypotenuse. So I'm missing the opposite. Maybe some of you have this one memorized. It's Pythagorean theorem, but do you guys remember it? 5 blank 13? 12, yeah. Okay, now if you forget it, you have to do Pythagorean theorem. It would be 5 squared plus x squared equals 13 squared. But it comes out as 12. Okay. I forgot words. Oh, yeah. Keziah, what would sine of D equal? Yeah, opposite over hypotenuse, yes. What would tangent of D equal? You're getting kind of quick with those. Quick on the draw. Okay, so on 6, 0.75 is like what in fraction form? So I would just, you could say it's like 0.75 over 1, but I would just think of it as 3/4. Do you guys remember the right triangle 3, 4 blank? Yeah, there's a 3, 4, 5 triangle. So that's basically number 6, so 3, 4, 5 triangle. Yeah. You could do 0.75 and 1. It would still eventually give you the, but it's more confusing probably. Just use 3 and 4 for the opposite and adjacent. Number 7. Okay, if you have a nice calculator, you can kind of cheat and use it. I know picking on you a lot. He doesn't, Kyle doesn't have one either. You're not alone. But you're almost alone. I give you permission to steal Isaac's. No comment, Isaac?
No comment.
You gonna stand for that? Okay, well, the way the book wanted you to do it, they actually, probably when they wrote this, they didn't know there were calculators that could, they hadn't made calculators that could do it yet. The way the book wanted you to do it is special triangles. 1, 2, square root 3. So sine of 30 would be opposite over hypotenuse. 1/2. Comma. Cosine of 30 is adjacent over hypotenuse. And tangent of 30 is opposite over adjacent. And 1 over square root of 3 becomes, yuck, square root of 3 over 3. For some reason I did not write very well. Anyway, that's all. Not that bad. So for 8, remember the 45, 45, 90 triangle is 1, 1 square root of 2. So you could use that picture for 8. Sine, cosine, tangent of that. Number 9. Says 60 degrees. So sine of 60, 60 is up here, so that would be opposite over hypotenuse. Cosine of 60 is adjacent over hypotenuse. And tangent of 60 is opposite adjacent. Square root of 3 over 1, which is square root of 3. Number 10 is, everybody's just use your calculator, just decimal, round to 4 decimal places. So no special tricks there. Number 11. All right, let's see if you guys remember. Wait, I'm gonna pick on Cadence. It's her turn. Sine of A equals 0.7314. All right, Cadence, how did we use this info to find angle A? Okay, I'm a little too deaf to hear you, but
That's what she said.
you said hit second sine. It's called sine inverse is what they call it, but yeah, you do sine inverse of 0.7314, and that'll spit out some angle, and they're telling us to round it to the nearest degree. So what was it round to? Oh, sorry.
47.0.
Yeah. Yeah. 47, whoops, I almost put percent. 47 degrees. Oh, that's just A. So on B, is just calculate work. Cosine inverse of 0.8828. Very easy problems if you know what to do, right? On number 11. But if you don't know what to do, that'll be easy points that you miss on the test. So you could get very easy correct points or miss them all. What'd you guys get for B? 28. And C? 26. Let's see, how far should we go today? 18. 16 through 18, that was the area worksheet we did. We didn't do the book assignment, so this it might be painful for us. We'll see how it goes. 13. It says solve each right triangle round to the 10th place. Isaac, what does that mean if it says solve the triangle?
I'm missing sides.
Partially. Find all the missing parts. So that would include any missing sides and any missing angle. So we need to find side C. And we also need to find angle A and B. Let's start, Isaac, with side C. Do you know how we could do that?
Yeah, 18 squared plus 27 squared equals 8 squared.
Yeah. So if you know two sides of the right triangle, you don't need you don't need trigonometry. You can just use Pythagorean theorem. On 12, however, there's only one side of the right triangle. So how would we find, like, say, side Y on number 12?
Use, the sine of whatever.
Okay, so relative to that 58-degree angle that they gave us, Y is the what side?
Opposite.
Opposite. 9 is the what side? Adjacent. Which trig function uses opposite and adjacent? So it's 10, 58 equals opposite over adjacent. Y over 9. Have we done this in a while?
Yeah.
We have? Okay, good. Can't remember the last time. You and the other class are kind of doing different stuff. Ah, that's a big number. Did you type that in?
Oh no. We had 9 squared and 13.
9 squared of 13.
Let's see, it's
Okay, I'll put it down. I'll put it in here. 9 squared of 13. Okay, but we're also missing like angle A and angle B. So, Isaac, any ideas how we could find angle A?
do like a 6 30.
Nope, nothing so nice as that. It'll be a really messy one. No? Caleb?
You?
Any ideas how we can find angle A here? Okay, do you guys remember on number 11, how did we find those missing angles? Sine inverse, cosine inverse, tangent inverse. So we need to do one of those. Okay, so starting with the angle, relative to this angle we're looking for, what sides do we have here?
Opposite adjacent.
Which trig function uses opposite and adjacent? So it's tangent of angle A, which we don't know right now, equals opposite over adjacent. So we need to plug in what to the calculator?
Tangent of 9.
Tangent inverse.
Tangent.
Just like number
27.
just like number 11.
56.3.
Okay, angle A is about 56.3 degrees. We could do something similar for angle B. We could do like tangent inverse of 18/27. But what's the easiest way to do angle B? If this is 56.3.
Then you just subtract it from 90.
Yeah.
Yeah.
These two acute angles in a right triangle should always add up to 90. So 90 minus 56.3 is,
33.7.
yeah. Number 5. What's not number 5, 15. A shortwave radio. Do you guys just see words and like your mind just goes blank? Is that basically how it works? A shortwave, well, let your mind create a picture. A shortwave radio antenna needs to have 3 support wires. What is a support wire? Yeah, if you look at it could be like a power pole or like a phone tower or something. There's usually like wires that help it stand up. So it's kind of like this. You know what I'm saying? Okay, and guess what it creates? A right triangle. So that's what we're talking about. The ground, the pole, and the support cable create right triangles. Where was it? A shortwave radio antenna needs to have 3 support wires attached to the antenna at points 15 feet from the base. So where's my 15 gonna go? The wire is attached 15 feet from the base. Yeah, like there's the base of the pole or tower, whatever it's antenna. The manufacturer requires the support wire to form at least a 35-degree angle with the antenna. Okay, support wire and antenna should make a 35-degree angle. So where should I put the 35 at?
Up top.
Yeah, the top one. Support wire, antenna. If the antenna is to be installed on a flat roof, determine the minimum length for each support wire. Okay, so in this picture, what would represent the length of the support wire? Yes, that's the support wire. And the smallest distance from the base at which the wires can be attached to the roof. Thought we already had the distance from the base.
That's the leg, the other leg.
Smallest distance from the base at which the wires can be attached to the roof. Oh. From the base of the antenna to the up here. So it wants both of those basically. Alright, I think Caleb.
Yeah.
Let's try and find the support wire length. I
Okay.
gotta find X. Okay, in trig we always start with the what?
The angle.
Angle. Relative to this angle,
Yeah.
what side are we looking for?
The adjacent, or the adjacent.
No. Adjacent is next to, but it's not it's the hypotenuse. We're looking for the hypotenuse, and the side that we already know is the opposite. Which trig function is opposite in hypotenuse?
Sine.
So I'm going to write sine what?
15 over.
No. Sine of what goes right here? 35. Then what? What's sine supposed to tell us? What ratio does sine give us? Sine equals what over what? Like SOHCAHTOA, sine equals over what?
Opposite of the hypotenuse.
So what's the opposite of the 35-degree angle?
15.
And what's the hypotenuse?
X.
Okay, how did we solve these equations when x was in the denominator? Times the x to get it off the denominator. So it just goes away. So we get like x times sine of 35. Then what do? Divide by, sine of 35 just represents some weird number that we don't know. But you divide by sine of 35. So basically the x and sine of 35 switch places. So it's x equals 15 divided by sine of 35 degrees. I'm getting warm actually. Good. It's cold. It's cool air. I have my jacket on. So. Alright. What does that come out to? Anybody plug it in?
58. I got it.
Does it tell us where we're under? Probably not.
Oh, I might be wrong now.
I think that's good.
That's not what they got. Did I put the 15 in the wrong spot? Oh yeah, I did. Let me read that again. The antenna at points, the support wire attaches to the antenna 15 feet from its base. Okay, yeah, I did put it in the wrong spot. Okay. The support wire attaches to the antenna. That would be this. Support wire attaches to the antenna 15 feet from the base.
So it's 15.
So the 15 was right there.
Okay.
Get those switched around. So we're going to have to change it now. So now, relative to my angle up here, I've got adjacent and hypotenuse, which is cosine. So we're going to have to use cosine. It's the same thing, but it's cosine. Cos. I think they round to the 10th place. Yeah. Okay. So I think they also want to know how far is the wire attached to the roof from the base, so the Y value right here. So Madeline, how would we set up for Y?
Could you just do the Pythagorean figuring out?
You could, but the problem is when you round a number off,
True.
a lot of times you'll get a little bit off on your, if you use it as an answer for something else. So Madeline, sorry. No, but yeah, I'm gonna say no to that. So relative to this angle, we're looking for the, and we have the, and which trig function is opposite and adjacent. So it's tangent equals, so on this one, the 15 is in the denominator. So yeah, to get rid of divide by 15, you multiply by 15. Okay, 10.5. Lovely. All right, you guys looking at 16? What shape is that they drew right there? Heptagon, 5 sides, is that right? 4, yep. 7 sides, I meant. The measure of each angle How could we find angle APB?
Let's see. You know, one of them is 16 inches.
No, we don't need that.
Oh, no.
So APB is the central angle made from that triangle that they drew, right? How many triangles would there be if we drew them all into the heptagon? 7 triangles. Yeah. So that central angle, angle APB, is 1/7 of 360. So it's 360 divided by 7. We're supposed to round that to the 10th place.
1.12. Okay.
Yeah. And then how would we find angle MPB?
Half of that.
It's half of that. So just divide your answer to A by 2. And then
Then you do.
how could we find angle PBM?
90 minus 25.
Right, those two angles should add up to 90. So 90 minus your answer to angle to B, angle NPB. And that would get you that one. Remember doing that in the worksheet? Maybe not. Okay, number 17, we're supposed to find how long MB is.
8.
So yeah, the whole thing, the whole length of the side of the heptagon was 16. They told us that in the picture. So how long is it from there to there? 8. Just half of it. And okay, on the last problem, I guess we kind of need our answers to the last problem. So we got like 25.7 up here. We got something else down here. But basically we need, for the B question, PM, which is this, we called it an apothegm at one point.
So what you do? Oh, what's it called?
So,
Tangent 25.7.
yeah, relative to this angle up here, we have offset and we're looking for adjacent. That's tangent. Tangent of 25.7 degrees equals opposite over adjacent. Are you serious right now? Alright, what'd that come out to? So remember when the x is on the bottom, those switch places. So it's x equals 8 divided by tan 25.7. What'd it come out to?
15.6.
Let's go like 4 decimal places on this one because it's not the final answer.
I already clicked on.
Done, clicked it off. Oh, they did. No, we'll keep with yours because they did tell us to do 1 decimal, but we're kind of need a. If you round it off too much, it kind of screws up your answer, final answer. Okay. Anyway, C. We're looking for PB.
So you do the Pythagorean is what you got.
Yeah. Or it would be opposite over hypotenuse, tan or sine. So sine of 25.7 equals 8 over y. Equals. lot of wood. Then on 18, we need to find the area triangle. Okay, the area of the heptagon. So there was a formula that we learned once upon a time when we did that worksheet on Monday. Is 1/2 times side times sine of the angle between. You guys remember that? What did we get on y, by the way? $18.4. So for the area of this triangle, and this was this angle was 51.4 degrees. So for the area of this entire triangle, we can do 1/2 times 18.4 times 18.4, we could square it, times sine of the angle between them, 51.4. Okay, but that would only find this bottom triangle, the heptagon.
You just have 7.
So yeah, there's 7 sides, 7 triangles in the heptagon. So you do need to add on a times 7 at the end of that. Tough one, huh?